In this video, we will discuss using 3D OSNAPS. If you'd like to follow along with this video, please open the file using 3dosnaps.dwg located in the Working Files folder as discussed in the Working with this Dataset video. Object snaps function the same way in 3D as they do in 2D, with the exception that you can optionally project them using the Z value. By default, the Z value of an OSNAP location is determined by the object's 3D location. However, if you work with object snaps on the plan or top view of a 3D model, a constant Z value is more useful. With running OSNAP settings, you can specify a point to an exact location on an object. Let's look at a quick example of using standard 2D OSNAPs in a 3D world. Let's say as a quick example, I wanted to draw a rectangle a certain distance above this feature right here. Note the UCS and the plane that it is projected at. When using regular 2D OSNAPs and starting a 2D command, you can use O tracking to acquire a point, move straight up. As you can see here, the Z is now being involved only. The XY is being grabbed from that point there. I can even type a distance in as long as you have the extension OSNAP turned on. So if I type in 5 feet, press enter, notice how the rectangle is placed at the parallel projection of the current UCS. Now let's do the same functionality. However, in this case, let's simply rotate the Y 90 degrees. And now we'll start the rectangle command again, acquire that same point, go straight up and type 5 feet, press enter, and now, as you can see, the rectangle is a projection of that parallel UCS. This can save you quite a bit of time and allow you to not actually have to move your UCS at all by simply using OSNAPs to acquire specific points and then using the Z value to get to the elevation you need to. Let's change our UCS back to the WCS and delete the rectangles. Let's talk about 3D OSNAPs. 3D OSNAPs are defined below here in the drafting settings. Let's go ahead and toggle it on. If you are not seeing 3D OSNAPs here, you can navigate to the customization button here and toggle on 3D Object Snap. If you click the little arrow, you can turn on and off the individual running OSNAPs. Just like 2D OSNAPs, 3D OSNAPs work the same. Let's go to the Object Snap settings and explain the different 3D Object Snaps available. The first one you have is Vertex, which of course snaps to the closest vertex of a 3D object. You then have Midpoint on Edge, which of course snaps to the midpoint of a face edge. You then have Center of Face, which will snap to the center of any face, whether it's a rectangular, circular, or any kind of shape a face may take. You have Knot, which allows you to snap to the knot on a spline. Perpendicular, of course, snaps to a perpendicular point on an actual 3D face. And lastly, you have Nearest to Face, which is not as useful as any of the other ones here because it will just snap anywhere along a face. We will discuss the point cloud OSNAPs in a future video. For now, let's toggle on Vertex, Midpoint on Edge, and Center of Face as running 3D OSNAPs, and click OK. Let's look at some examples of how we can use 3D OSNAPs. Some of the commands we're going to use in this video, we will discuss in greater detail in future videos. For now, we just want to examine the OSNAPing and 3D OSNAPing functionality. Let's navigate to the box command here and make sure our layer is set to A-window. We want to draw a window for this part of our building. Make sure that you have dynamic UCS turned on and select the center option in the command line window and then simply hover over the face of the wall here. Notice how the 3D center OSNAP activates and you can simply click. You are now drawing on that object's face and the UCS changes to this plane. For dimensions, let's type in 6 feet, 4 feet, press enter, and now for a width, we would like to type in 10 inches for that. Notice how the UCS goes back to the WCS, which was defined before. Let's use the subtraction Boolean command to select the wall first, press enter, select the window next, press enter again, and now we've subtracted out that window. Let's look at another example of using 3D OSNAPs. Let's go ahead and change our layer to the A-roof layer. And let's say we want to draw a polyline a certain distance above this point here, and then drawing it perpendicularly to the wall all the way around the actual posts here. Let's go ahead and turn off dynamic UCS as we no longer need it. And let's go ahead and just start the polyline command. Let's say we want to start this roof a certain distance above this point here. So again, just using regular AutoCAD, we can acquire this 3D vertex, go straight up and type in 6 feet and press enter. It starts that point at 6 feet above. Now we want to be perpendicular to this face here. So we'll shift right click, 3D OSNAP, and choose perpendicular. Just like regular 2D OSNAPs, you can do a 3D OSNAP override as well. Hover over the face and simply left-click, and you're done. We'll do the same thing here. Now, because this is a polyline, we can simply snap to the endpoint there. It automatically goes to that point. We'll do the same thing here, simply grabbing this endpoint. Notice how it projects it automatically. Left-click and type C for close. And there's the outline of, let's say, our future roof. So 3D OSNAPs work with all the functionality in AutoCAD, just like regular 2D OSNAPs do too. Let's go ahead and just start the move command. And as we zoom in here, we realize that we need to move this post here to the face of this solid. So we'll go ahead and select that object, press enter. I want to grab the center of the face, so I'm going to grab the center of the face like so, and then do a shift right click and simply choose 3D OSNAP, perpendicular, and simply hover over this face here and left click. And automatically it'll snap from that center point of the face perpendicularly to the actual face of this solid here. You will use 3D OSNAPs tremendously when designing in 3D, as they allow you to draw stuff without actually having to change your UCS.